It's Don here from the board. Thanks for coming along and checking out this video. So today I'm going to be having a look at a very simple tool, I believe, but it's a very important tool for soldering. And of course we do a lot of soldering for building our keyboards and the alike. And what I'm talking about today is a soldering iron temperature tester. The actual product has been sent to me for review from Banggood, and as per usual, everything and anything that I say is my opinion only, and this is not a paid advertisement or review of their product. So let's just have a quick look at the actual product listing so we know what we're trying to see and what we're expecting, and then let's give it a test. Okay, so here it is. It's the 191 soldering iron tip thermometer sensor line digital tester temperature test. Wow, they really love their mouthfuls of titles. It's quite cheap. It's only $11 at the moment. You could probably get some kind of sale price. It's a very simple looking device, and it's doesn't come with batteries. So I do have a battery, but I think it might not be any good. So I might have to pinch the battery out of my multimeter to put it in. And yeah, it's meant to help you actually test your irons. Now, why is it important to actually test your soldering iron and the calibration on it? Is because, well, you don't want to be trying to solder at too low a temperature, and also at the same time you don't want to be soldering at too high a temperature. But how would you know that unless if you have a means of accurately measuring the temperature that your tip is producing? And that's where this device comes into play. So let's have a look. Let's crack open the package. This is really interesting because it came in this, and it's actually the first time I've seen anything that I've been sent previously in Banggood actual plastic. Typically it just comes in your standard sort of black or grey plastic, so they're kind of upscaling, which is nice, I guess, for them, and just covering my address details. But I find it fun that they've got the logo there, not logo, the catchphrase, best bang for your buck. Whether that's true or not, only you can decide, right? Some of the things I've looked at have been a little bit dubious in terms of quality and function, but hey, what can I say? Rightio, so there it is. There's the HB191 thermometer from HB Tool, a standard sort of SKU made in China. It's nothing fancy around on the outside. Let's open it up, and oh, look at that. It actually they do give you a battery. Huh, that's interesting. So they're using Hakko sensors, which I find is really interesting. Now, whether these are legitimate ones or not, I don't know. 2019, earlier in the year, made in Indonesia, which is interesting. Now, Hakko obviously make one of these, otherwise they wouldn't have the sensors. So let's pull out the unit, and they give you a plastic wrap battery. So that's cool. I'm not going to have to strip my multimeter apart. Okay, so instructions are in Chinese or whatnot. Yep, just in Chinese. Now, my understanding is that the sensor it's a K-type sensor arrangement, and you'll notice that the diagram here actually has this midpoint and it's got these hook points. The actual device itself, I'll take it out of the plastic so we can sort of see that a little bit better, since we obviously can't use it in the plastic. Broke a bit of tape off there. Whoa. What's it caught on? It's caught on the probe. There you go. I don't even know where that non-slip foot came off from, because there's only one of them. Good job. Put that back in. So you'll see there's a red dot, and that's meant to be a blue dot over there, and then it's actually spring loaded. It's meant to be spring loaded. It's very, very strong spring loading. Oh, there we go. So yeah, so you push that button and that that actually moves. That part there moves. So the sensors have color, red and blue, and then of course the top part, and you hook it on and it puts a bit of tension on it, and you actually put some solder on it and hold your iron into the middle of it, and it's meant to tell you what temperature it is. Now, because I can't read Chinese, I can't really tell you very much about what this is trying to tell me, except it looks like it'll measure, that must be Celsius, I think, up to 500 degrees Celsius. So 300 to 500 degrees Celsius. So if you're looking to measure below that kind of temperature, it's probably not going to be fantastic. But if you want to be measuring around 3 to 500, it should be good. So first of all, let's open it up, put a battery in. Paco, super heavy duty. 0 mercury, 0 cadmium. Okay. Made me pull out my screwdriver for no reason, because I thought I'd have to potentially take my multimeter apart. Okay, let's get that in. Tuck that in. Put that back in the box because it's not going to do us any good anymore. Come on. There we go. And it's measuring 1 degree C. So let's just turn that off for the moment. 1 degree C would be very worrying. Oh, okay, so that plastic just broke. I'm going to have to get a little baggie. And well, they come in a little baggie anyway. This packaging is interesting in terms of its snap design. Now that's a folded, or is it one? No, it's just a solid piece. There's nothing in between to talk about. Let's pull that out. These things are very, very small. And how they folded this packaging. There we go. There's the edge. Let's just get one out. There you go. It almost looks like a flux capacitor, for anybody who knows that reference. I'm not really gonna be ageist and assume that certain generations won't know the reference, but you never know. There's plenty of other good films out there, so they might not have come across it. Right, let's just put that back in the box. So let's hook up one side. Oh, come on. There we go. It's a bit fiddly. Maybe this will help with my uncoordinatedness. There we go. And then put that down. Let's grab that one. Oi. There we go. Make sure it's down on the base on all of them, and then now it's under tension. There is plastic film there. I know that somebody had a gripe on one of my other videos because the plastic film was still on it. I'm just wondering if it's peelable so it doesn't have that reflection. No, it doesn't look like it's lifting off readily or easily. Oh no, there we go. This is going against all of my Asian-ness to actually do this and peel that plastic film off. So I hope you appreciate how much this is causing my internal sense of identity. Of course, I'm not going to try and take that sensor off just to take the plastic off, because that was such a pain to get it on. Rightio. Not that it did very much, because the underneath is just as glossy. GG. Rightio, but you'll see that there's the color dots, the colors on the actual wire now line up, and it's smack bang in the middle. So let's turn on my iron. Let's get the battery out of the way so it's not going to be at risk. Let's move that out of the way. Okay. So at the moment, it's just going to heat up. I didn't tin it properly after I used it last, so I know anybody who's looking is probably going to be going, oh, what's wrong with you? Your tip, it should be about 300 degrees or so, I think, from memory from last time I used it. Yeah, so it's just trying to stabilize at 300 now. So this is the TS80 soldering iron. There we go, TS80. Try not to burn myself. And I've got it currently going at 300 degrees. So let's just re-tin and clean the tip. So that way it's going to be nice. Now, the usefulness of having something like this, if it works and does what it's meant to do, is you'll know if your digital calibration is correct, for one. But if your digital calibration is correct and you're still not, and your tip is behaving strange, it could be that the tip is on its way out because it's just old, right? Over time, metal fatigue and everything else, it's just not transferring heat very well, or the thermocouple is not working properly. So that's another reason to have this, because you can check periodically if you believe that something's not going quite right. Okay, so I'm going to tin this without it being on first, and then I'm going to let it cool down, because I did watch on the internet about how you're supposed to do this. And the reason why you do it is because you kind of need to transfer the heat through the solder into the actual wire. You can't do it just by a bare tip onto the actual wire in the sensor. So now that we're going to turn it on, it's already telling me it's 107 degrees, and you can see it's cooling down pretty quick. So that's actually really interesting from a point of view. Now let's just get that to cool down fully. My iron's still holding its temperature. You can see how fast or how slow that curve is as it's cooling down. So I'm pretty comfortable with it now being down in the 40s. Not too bad. So let's just ramp it back up. So it's reading about 309, 308, 309 degrees. So that's about 9 degrees off. So let's just change the iron now. So let's go up to, say, 350. So let's wait for the iron to ramp up and stabilize. Okay, so it's hit 350. We'll give it a little bit to sort of stabilize itself there. Let's re-tin it. Okay, temperatures come back down around to the 40s again. So let's just give it a little bit of fresh solder there. And so you want to just be touching it, but you don't want to be pushing it too hard. And look at that. I'm now actually quite a bit over at 368. So before we were 9 degrees off at 300. So 9 times 5 is 45. 45 plus 350, you know, it should be reading around 390 if it was linear, so it's not. So we're only about, what, 18 degrees over, so it's double that. So let's have a look at if we go up even further. Let me just reset the temperature to 400 degrees. Okay, so it's just trying to stabilize at 400 now. Right, so it looks like it's okay. Let's just look how fast it's just vaporizing my my solder there. So we're down to 30 degrees on that, and it's reading about 430, 431, 432. Okay, so we've gone from being about 18 degrees over at 350 to 32 degrees over at 400. Now that's less than a 10% error at 400, but it's still quite significant. Now what's the accuracy of this? Honestly can't tell you, because I don't have any other way of countering that. But what it does tell me is, if this is to be believed, so let's just go down to say 280, just for some testing. I'm gonna have to wait for it to cool down, because it's trying to come down at the moment. It's just ticking over. The important thing is, if you're using a soldering iron on something and it's quite heat sensitive, you want to use the minimum amount of heat required to get the job done. Excess heat that you put into your actual solder job is going to transfer into components, it's going to transfer into the PCB, you can lift pads, you can burn traces, you can burn components, so on and so forth. So having an accurate indication of what temperature you're working at is really, really important, and that's why these devices exist. So now that I've done this very basic testing, if I believe this unit, and unfortunately I don't really have any other means right now to challenge this, I know that my iron is running on the hotter side than what's actually written. I know that the TS series can be firmware changed, programmed. You can actually hook up into it and control that. So in theory, if I wanted to, I can just go in and tweak it. Thankfully, I don't actually work with anything that's super duper sensitive. But look at that. So we're reading about 8 degrees over still at 9 degrees over at 280 degrees. So yeah, it's consistently reading about 9 degrees thereabouts at the 300 or lower mark. And then when I go up to 400, I'm actually reading 430 degrees thereabouts. So about a 9% kind of error in that range. How useful is this for you? Well, if you've got a digital one and you want to play with the calibrations, it's probably a good idea. If you've got a fire stick, like, you know, a 15 watt, a 20 watt, something like that, and you want to know what kind of temperature it's actually outputting because it's not temperature controlled, then this is also really useful for you, because you can see what kind of temperatures it's actually cranking out, and therefore work faster or slower accordingly and be a little bit more at ease on what is going on. Rightio. So, quick and easy to play with, very easy to use. Supposedly, these sensors are only good for a set number of measurements before you have to replace them, which is why they come in a pack of like 5 or 10, depending on where you get and what you get. It's not massive, but it feels quite hollow. It probably could be a smaller unit on design, but I don't know what kind of electronics is actually behind all of this. Can I be bothered to take it apart to check? No, not really. But yeah, it's definitely something useful to have as part of your electronics kit if you're going to do a lot of soldering and you're kind of being serious about it. So there you go. There you have it. The HB191 soldering iron tip thermometer. You can get it, of course, at Banggood. And once again, thank you to Banggood for sending me this to check out and play with. And yeah, if you check in the video description below, hopefully there might be a code that could give you a discount. Otherwise, there should be a link to the product and you can go check it out for yourself. So yeah, I just want to wrap up by saying it is actually still November right now, and it means Movember. This is my 7th year running, and as you can see, I've got a bit of a dirty mo going on. It's in support of men's health all around the world. It doesn't matter where you are, but you know the impact of things like men's mental health, testicular cancer, prostate cancer, and so on and so forth affects a lot of people. So if you want to get involved, if you're not already involved, please check out the link below to my Movember campaign. And if you have the ability to, I would love and appreciate it if you could make a contribution. All right, that's it. Thanks very much for checking out the video. And yeah, as always, until next time, happy clacking.